Okay, we are starting Unit 5 on polynomials. The first part of Unit 5 we are going to do basically combining like terms. So just some basic definitions. A monomial is one term. And an example could be just like the number 5 could be a monomial, or you could have something like 5x is a monomial. Terms are separated by plus or minus signs. So a binomial would be considered two terms. And a term is separated by plus or minus, so we could do like 5x plus 3. That could be considered two terms. The 5x is one term, the 3 is a separate term. You can probably guess trinomials are three terms. So let's say we add in like an x squared plus 5x. We'll do minus 3. Doesn't matter, these are separated by a plus sign or a minus sign, they represent three terms. Polynomial, which is what we're talking about today, adding and subtracting polynomials, refers to many terms. So when we say something like combining like terms, you might only have two terms, you could have three terms, you could have a lot of terms, but the general term for polynomial just refers to different types of terms. Alright, so if I was going to say what are we adding here, this is called a binomial plus another binomial. When you are adding like terms, you want to add things that have the same variable and the same exponent. So we'll say like terms equals the same variable, or lack thereof if it doesn't have a variable at all, with the same exponent. And what I mean by that, an x squared and an x cubed are not the same like terms. They both have the letter x, but the second power and the third power would be different. So this one, first thing you do, if there's a plus sign, there's nothing to distribute, because if you think about the number in front of that parentheses is a 1. So if you take 6 times 1 and 9 times 1, it doesn't change those numbers at all. So we'll just bring down the first parenthesis. Again, 1 times 6 is just 6. 1 times 9 is 9. So it doesn't change any numbers there. So once I've gotten rid of my parentheses, we're going to see which ones are considered like terms. So the 4y and the plus 6y would go together to make 10y. And then the other ones would go together. We would have minus 3 and a plus 9. So when you're thinking about that, combining like terms, negative 3 plus 9 would give us positive 6. And that whole thing is your answer. You can't go any farther because this one has a y and this one doesn't. So that would be combining like terms. Now we're going to do some that have exponents. We did some about this level before. Now we're going to do ones with exponents. Again, if this is an addition problem, if you distribute a 1, it's not going to change any of those numbers. So let's just write them out without the parentheses. And on this one, since there's so many things, I'm going to show you the way some textbooks do it, and they do it sometimes on error analysis. They group them. So like one option is to underline which ones go together, or circle which ones to go together. Another option is to rewrite the ones that go together. So the cubes need to go together. So you could regroup it and say 2x to the third plus the 4x to the third. Those ones need to go together. And then you could go, okay, well, the x squared needs to go with this x squared. So we're going to do plus. So you're going to kind of put the terms that go together next to each other and then simplify. The last one, it looks like I have a minus 10x and a plus 5x. So I've color-coded them. You don't have to do that. Again, you could just circle or underline and decide which ones go together. When you're adding or subtracting with numbers with exponents, you add or subtract the numbers in front. So like the coefficient here, these are like terms, so 2 plus 4 gives me 6, x to the third, okay? You keep the same letter and the same exponent, you just add the two numbers together. So this one and this one, 7 minus 9 is minus or negative 2x to the second. And the last one, these two now go together, negative 10 plus 5 would give me negative 5x. So this whole thing is my answer. This is kind of like my answer for the x to the third. This is my answer for the x to the second. This is my answer for just the x. But you can regroup them together and then add them or whatever you need to do. Okay, so why don't you try the next one on your own. This is again an adding one. So in adding one, if you have an imaginary 1 here and you distribute 1 times negative 5, 1 times 4, 1 times 11, it doesn't change anything. Your first parentheses always stays the same. That last one, you'll notice I start with the third power, then the second power, then just an x. Typically, they want to put them in what's called descending order, the biggest exponent until it gets to the smallest exponent, or no or exponent. This one's a little unique because we have a squareds and we have b squareds. And so, when they have something like that, they usually put the a squareds first and the b squareds at the end. I'm not going to be in particular about which order you write your answer in, we just want to make sure you can group them and combine like terms correctly. So we'll just start with like the a squareds. Okay. Then let's see, the next one we have are these ABs and ABs. And it looks like the last ones I have are these b squared ones, so minus 7b squared and plus 11b squared. So again, just grouping them together by their letters. These have the same letter and the same exponent, so those two go together. So 3 minus 5 gives me negative 2a squared. Then these two combine, 2 plus 4 is going to give me 6ab. Again, you keep whatever letters are next to it. Negative 7 plus 11 gives me a positive 4b to the second. So again, all those things are different terms that cannot be combined together because they have different letters by them. Alright, let's look at, now we're going to do some subtracting. Now if you think about subtracting though, if this is a 1 here, remember on the last one when we multiply by 1 it didn't change anything, but when you multiply by a negative 1, it does change numbers. So we have 12m plus 4. You always distribute the parentheses it's next to. So negative 1 times 1 is negative 1. Negative 1 times negative 3, two negatives make a positive 3. Now we're going to combine our like terms. Again, you can rewrite them like I did on the last two, or you could just circle which ones go together. The 12m goes with the plus 3m. So those are going to give me 12 plus 3 is 15m. And then these two in the middle are the ones without any letters. So 4 minus 1 is positive 3. So that whole thing is my simplified form. You can't add m's to ones that don't have m's. Of course, now we have a little bigger version. Again, if there's a minus sign here, it's like a negative 1 that we need to distribute times each number or term that you see in that parentheses. First parentheses stays exactly the same. Now we'll distribute negative times negative makes positive 4xy. Negative 1 times 2 is negative 2y squared. And negative 1 times negative 8 is positive 8x squared. Now again, there's a lot in this one, so I think I'm going to group them together, try and write them side by side. Doesn't matter which one you start with, so I'm just going to do this one. And remember, you always keep the sign that's in front of it. So that y squared should go with this y squared. Okay, the next one I see is this plus 5xy. And another xy I have is here, plus 4xy. And then the last things I have are these two, the ones with the x squareds. So now I've grouped them based on their letters, and now we'll actually add or subtract those numbers. These are called coefficients. The numbers in front of a letter is a coefficient. So I'm going to take negative 3 minus 2, and that gives me negative 5, and you keep the same letter. Let's look at this one. 5 plus 4, the coefficient, so 5 plus 4 is 9. Keep the same letters. 7 plus 8 is 15, and I'm going to keep that same letter, x squared. So when you are adding, it does not change any exponents or letters. You just have to put the same ones, match them up together. So this whole thing is my answer. Alright, last one. Again, this is a minus 1 here, so we're going to distribute the negative 1. First parenthesis stays exactly the same. It's a long one, but now negative 1 times 6 is negative 6. Negative 1 times negative 11, two negatives make a positive. Now we'll group them together. I started off with 5a to the third, but if I look, I don't have any other a's to the third, so I'm just going to literally bring that one down by itself. There's no other ones like that. Okay? Then let's do our a squareds. 4a squared minus 6a squared. Okay? And looks like we just have an a. And I have two more things, but that was my only a, so let's see if I can find another color here. Plus 2 and plus 11. So, sometimes you don't have anything to add to it. Like this one didn't have anything to add to it. It was all by itself. These a squareds, 4a minus 6a is negative 2, or we say minus 2a squared. There's no other ones that just have an a, so I bring that one straight down. And then the last one I have is 2 plus 11 would be 13. So this whole long thing is the answer. And sometimes there's things to combine, sometimes there's not. But watch, if it's a minus problem, you have to distribute the negative 1. So you have to times by negative 1. Alright, let's apply this now to some picture problems. Perimeter just refers to adding something. So given this picture, it says, given the rectangle below, find the simplified perimeter. So if it's a rectangle, we know that opposite sides are going to be equal. So this side is also 2x plus 3. The side on this side is x plus 1. So if I was going to write out a long addition problem for perimeter, it would look like 2x plus 3 plus x plus 1 plus 2x plus 3 plus x plus 1. So this is our perimeter. You add up all your x's, and you can do that in the picture by looking or counting up your x's. I'll just underline them: 2x plus 1x plus 2x plus 1x. So 2, 3, 4, 5, 6. The perimeter would be 6x plus. Now let's do our other numbers. We have 3, 1, 3, and 1. So 3, 4, 5, 6, 7, 8. We have plus 8. That's called the simplified perimeter, because we have added our like terms. Now it says, if the perimeter is 26, find the dimension. Is means the word equals. So I'm going to take 6x plus 8 equals 26, and I want you to solve it. You remember from first semester to solve, you would subtract 8 to both sides. Let's see, 26 minus 8 is 18. And then you divide by the coefficient, so divide by 6, x equals 3. The word dimensions means plug that number in and find like your length and your width. So if you plug a 3 into your picture, 3 plus 1, that equals 4. If you plug 3 up here, 2 times 3 plus 3, 2 times 3 is 6, plus 3 equals 9. So the word dimensions, that's like your length and width. So we could say 9 by 4. Because those are inches within inches. So 9 inches by 4 inches. Those would be the length and the width of that. Alright, so that was a pretty complex one. Adding, which we just practiced, and then also involves solving. Let's try this one. It's a little smaller. We have just a triangle. Perimeter is adding up all your sides. So you can add them up visually. You can just take all the x's, 5x, 4x, and 6x. That equals, all those x's add up to 15x. Then add your numbers. You have 2 and 8 and negative 4. If you add that together, that's 10 minus 4 is 6. The reason I put the 111, it says is 111, so that means equals 111. Now we're going to solve. Subtract 6 to the other side. And divide by 15. Get x by itself. It says solve for x. So x equals 7. So perimeter is adding up the sides. If it wants you to go further, then you would solve for something. This one only says to simplify the perimeter, which means you're only adding up your sides. This one, though, we have x's in the problem, and we also have x squared. So this might be one you want to write out, if that's helpful to you. And do like we did the front side of the paper. So like if I wanted to do like the x squared, this is a 1x squared when there's not a number with the x squared. So those x squareds go together. Then you can do the numbers any way you want. I like to do the x's next. So 4x and 5x. And then really the only thing I have left are all these purple numbers. So I'll do plus 7, plus 3, minus 5, minus 2. So now by writing it out and regrouping, I can see we have 1 and 3, so 4x squared. We have 9x. And then that gives me 7 plus 3 is 10, minus 5 is 5, minus 2 would be 3. So this is what's called the simplified perimeter. Okay. Again, just more practice with perimeter, adding up the sides. This one's a little different. It doesn't say equals like a number. It tells us it equals something else. So perimeter, if we add up all these 9x, 9x, and 8x. Let's add the x's. 9 plus 9 plus 8 is 26x. 26x. And if I add just the numbers that are left, 12 plus 12 minus 11 equals 13. I could circle those. plus 12 plus 12 minus 11. That's going to give us positive 13. So that's what I got from adding those up. This time, instead of saying it equals like 111, this one says it equals 22x plus 25. Could we use that to solve then? To solve or find the value of x. This is when you have variables on both sides of an equation. You want to subtract your variables to one side. So you get 4x plus 13 equals 25. Now this becomes just our regular two-step equation. We went to minus 13 away from the x's. And then the last step is division. Alright, so some applying problems of how do I use this when combining like terms. This is perimeter questions. Now we're going to do what's called error analysis. Somebody has worked this problem out and made a mistake. So circle the step where the error occurs. So what I would suggest doing is doing it to the side and see if you come up with the same answer. And as you're working out, see where your step might be different than their step. So this is plus 1. So plus, that means we're only going to keep them exactly the same. There's no number to distribute besides a 1. Okay. So my step here looks the same as that. So I'm going to put a check mark. Our answers matched. Okay, it looks like then they regrouped them together. So let's try regrouping them. The x to the third plus the 4x to the third. And then if I grouped my x's together, I would have minus 7x plus x. And then the last one I would have is plus 2 and plus 6. Okay. Do we group them the same? Well, that first part looks the same. Here, this looks a little different. I have a minus 7x, and they have a positive 7x. They put a parenthesis here. And 2 and 6 is, they got 8. So let's just try. This and this comes up with, remember that's a 1, so that's 5x to the third. This should come out to, remember, a 1, so negative 7 plus 1 is negative 6x, and then we should have plus 8. Well, now if I look at our answers are definitely different. So it seemed to be the first place we had a difference was right here. So I would circle right here is where my problem turned out different than their problem. Describe the error. I would say they didn't keep the negative with the 7. And you could put negative, or you could say minus sign with the 7. Simplify it correctly, which I did. This is my simplified work. I just did it up here and set it down there. Okay, so that is error analysis. You're going to take the problem that they give you and work it out and figure out where is your problem different than where their problem is. Because they're telling you they made a mistake. Figure out where is the mistake.